16.1 is integration by parts. So typically when you learn integration by parts, there is this formula that goes with it. The integral of u dv equals uv minus the integral of v du. If this is how you learned it and you're good at it and you like it, then go with it. I'm going to teach you a different way. So what I'm going to teach you is how to use a tabular method. So you're going to be seeing two types of problems, and we've already gone through all of the basic integration rules and then all the u-Svdu rules. So the big question is, how are you going to know when to do integration by part rules? And here's going to be my best explanation. So if you have an e to the x and it is an x to the 1 power, so it might be a number in front like that, okay, but it's still x to the 1 power. And you have an x term being multiplied to it. So it could be like x plus 5 e to the 5x. But the key things are it's x to the 1 and there's an x being multiplied to it. Then you know that's going to be integration by parts. If it was just the integral of e to the 5x, we know how to do that. That's just 1/5 e to the 5x. The key is it's not just e, it's being multiplied to an x. Also, if it were e to the 4x squared, that doesn't count either because it has to be x to the 1 power. Okay? So that's how you know that the e is going to be an integration by parts. So we're going to do the e problems first. There's 3 of them, numbers 1, 3, and 5. This is what you do if you're doing integration by parts for an e problem. You're going to draw a little chart, and on one side you're going to be finding the derivative. On the other side you're going to be taking the integral. And if there's an e in the problem, that e will always go with the integral, and the other stuff will always go over here with the derivative. What you do is you take the derivative until you hit 0. So derivative of x is 1, derivative of 1 is 0, and you stop. You're now going to integrate the right side the same number of times. The integral of e to the x is e to the x. The integral of e to the x is e to the x. So this is, we're doing easy, medium, hard here. This is our easy problem. You then come in here and you say plus, minus, plus, and you draw diagonals. And this is going to equal, reading our diagonals, a positive x times e to the x minus 1 times e to the x. And then don't forget your plus c. And that's it. So we're going to skip to number 3 a second. We know this will be an integration by parts problem because it's x to the 1 and it's being multiplied to an x. Okay? So I'm going to make myself a little chart here. Derivative on one side, integral on the other. Your e term always goes under the integral. Everything else goes under the derivative. You're going to take the derivative of whatever term is there until you hit 0. Derivative of x is 1, derivative of 1 is 0. You're going to integrate the same number of times. So the integral of e to the 5x is 1/5 e to the 5x. And then think about what the integral of 1/5 e to the 5x is. That's going to be 1/5 times the integral of e to the 5x, which is 1/5 e to the 5x. So that 1/5 being the 1/5 that was already there. So it's going to be 1/25 e to the 5x. And you do plus, minus, plus, drawing your diagonals. So we're going to have a positive x times 1/5 e to the 5x minus 1 times 1/25 e to the 5x plus c. Now, so usually we write the number out front But if you're just typing this into an online homework, you can type it in however you want to. If this were a multiple choice thing, they'd probably write it in front, but I don't even know what it's going to be yet. All right, let's jump to number 5. How do we know this is an integration by parts problem? Because our exponent is x to the 1 power, and there's an x term being multiplied to it. So this is integration by parts. All right, so we have a derivative side and an integral side. The integral side, we always put the e term over there. Derivative side, we put whatever's left. All right, so taking the derivative until we hit 0. Derivative of 6x plus 3 is 6. Derivative of 6 is 0. The integral of e to the negative 2x is negative 1 over 2 e to the negative 2x. And think about what the integral of negative 1 over 2 e to the negative 2x is. You could pull that number out front. And so you'll have negative 1 over 2 times negative 1 over 2 e to the negative 2x. So 1/4 e to the negative 2x. Do your positive, negative, positive diagonals. So we're going to have a positive 6x plus 3 times negative half e to the negative 2x minus 6 times 1/4 e to the negative 2x plus c. So if it's making you reduce this, I mean, that's a great answer. Boom. Love it. If it's making you reduce this to type it in or whatever, you could multiply this through if you wanted to. So 6x times that would be negative 6x times, 6x times negative half is negative 3x e to the negative 2x. And then 3 times that is minus 3/2 e to the negative 2x. And then right here we'd have minus 3/2 e to the negative 2x plus c. This is only if they have and you reduce. And then those two terms can be combined. So negative 3x e to the negative 2x. If we add negative 3/2 plus negative 3/2, that's negative 1.5 minus 1.5, you're going to get negative 3. Did I do that right? Checking myself. Been a long day. Negative 3/2 minus 3/2. Yep, negative 3. All right, so that's the simplified version. All right, so you're halfway through this integration by parts lesson. So that's how you do integration by parts for an E term. Now let's go back to problem number 2 and talk about how you would do it for a logarithm. In order to show you how to do it for a logarithm, I'm actually going to make number 2 a little harder because it's slightly too easy to explain. So we're going to change this to the integral of, we'll say the integral of x times natural log of x dx. So then the big question, how do we know to do integration by parts on this versus u substitution? If it were a u substitution and there's a natural log in the problem, the natural log has to be the u, right? So when you go to find your du, derivative of natural log of x is 1 over x. So over here in the problem, you would have to have an x in the denominator in order to replace it. If there is a natural log in the problem and there's not an x in the denominator, then it's not u substitution. You have to do integration by parts. Okay? Let me say that again. If there's a natural log in the problem, in order to do u substitution, you would have to have an x in the denominator. So if there's no x in the denominator, then it's not going to be u substitution. It's going to be integration by parts. So let me show you how to do this in the tabular method. It's a little different. All right. So So we have the derivative side and the integral side. If there's a log, it always goes on the derivative side. Everything else in the problem goes on the integral side. Okay, unlike E, we only take the derivative once. Derivative natural log of x is 1 over x. And then we integrate the same number of times. So the integral of x would be x to the 2 divided by 2. Don't worry about the plus c yet. So it's 1/2 x squared. We're going to have positive, negative, diagonal, and careful on this one. I'm going to draw an arrow right there, and I'm going to draw the little integration sign. Okay, hang with me. It's really not hard. So we're going to start by taking a positive natural log of x times this term. I usually write the second term in front, times the natural log of x. Otherwise, computer will think you're trying to do the natural log of a whole bunch of stuff. Minus, now what this is saying is you want to do the integral of these two terms multiplied. Well, let me give you a hint. These two terms multiplied will always be this term with 1 less x. So this term, x to the 1. Okay? So minus the integral of 1/2 x. So you got one more step to go. So this one will stay 1/2 x squared, natural log of x, minus, I'm going to integrate this. So it'll be 1/2 x to the 2 divided by 2 plus c. So I end up with 1/2 x squared times natural log of x minus, dividing by 2, same thing as multiplying by half. So 1/2 times 1/2 is 1/4 x squared plus c. It's all right, if I lost you on that one, we got 2 more to go. So we're going to skip over to number 4. All right. It has a natural log in the problem, and because there's not an x in the denominator, then I know this must be an integration by parts. So this is my derivative side, my integral side. My natural log always goes on the derivative side. The other stuff goes on the integral side. We take the derivative 1 time for natural log, and we integrate the same number of times. So the integral of x to the 3rd is going to be x to the 4 divided by 4. Don't worry about the plus c yet. So we will have 1/4 x to the 4th. Do your plus and your minus. Draw your diagonal. And this one's going to be an arrow with an integration sign. So we're going to have a positive natural log of x times 1/4 x to the 4th. I'm going to write 1/4 x to the 4th first. Minus the integral of these two terms multiplied together. These two terms multiplied together is always going to be this term with 1 less x. So 1/4 x cubed. So this part's going to stay the same. And I'm going to integrate 1/4 x cubed, which would be 1/4 times the integral of x cubed, which is x to the 4 divided by 4. So I end up with 1/4 x to the 4th, natural log of x, minus, dividing by 4, same thing as multiplying by 1/4. So I have 1/16 x to the 4th plus c. Not too bad. And one problem to go. All right. So we have a natural log in the problem, but there's no x in the denominator. So that tells us it's going to be integration by parts. This is our derivative. This is our integral. The natural log of x is the derivative side. On the integral side, we'll put 4x plus 9. We take the derivative 1 time. We integrate the same number of times. So the integral of 4x plus 9 would become 4x squared divided by 2 plus 9x, which is 2x squared plus 9x. We put a positive, we put a negative. diagonal, and an arrow with an integral sign. So I'm going to have a positive natural log of x times 2x squared plus 9x. I'm going to write the 2x squared plus 9x first times the natural log of x minus the integral of these two terms multiplied together, which is going to be this term with 1 less x everywhere. So it would be 2x to the 1 plus 9x to the 0. So this is all going to stay the same. Minus the integral of 2x would become 2x squared divided by 2 plus the integral of 9 would become 9x to the 1 divided by 1 plus c. Notice how I put these parentheses around it right there. I did that because I'm subtracting and I want to make sure I distribute my negative sign. So I have 2x squared plus 9x times the natural log of x minus, the 2's will cancel, so x squared minus 9x plus c. There you go. Integration by parts.